Okay, so let's look at the sequence of numbers here. We have the terms at the top, and we have the values at the bottom. And the first value being 2, second 4, third 8. So you see an obvious pattern here where the values are doubling each time. Um, so we can call this a geometric sequence. And remember, geometric sequence is something that uh, is increasing through multiplication. Okay, and the number that we're multiplying to get to the next term we call the common ratio. So in this case, 2 times what gives you 4, 4 times what gives you 8. So the common ratio would be 2. And I'm going to just make a note of that here and keep that to the side. I'll put it actually off to the side here. Alright, so I'm looking at the recursive formula here, and it says here f of n equals f of n minus 1 times the common ratio. Again, just to review, remember recursive formulas are pretty straightforward. You're always looking at the term before the term you're trying to find, and just look for the pattern. In this case, it's times 2, and you are multiplying that the last term that's given to you by that same amount and getting the next term. But obviously, if I put this into a function notation using the recursive formula, it looks a lot more complicated. But basically, this part right here, f of n minus 1, is really trying, the f of n minus 1 is really the representation of this fifth term. Okay, so what you have here is, remember, the n is the term I'm trying to find. In this case, this is the sixth term. So let me start with that. So I have f of n, the sixth term. So really, if I'm trying to figure out the fifth term, okay, what I do is go back one. So 6 minus 1 gives me 5. So that's how I get my fifth term. Um, so what I have here is f of 5. 6 minus 1 is 5. Times, let's go ahead and change the ratio to 2. Alright, so what do I have here is the f of 5 times 2. F of 5, if you look at the table, is the number 32. So I'm going to replace f of 5 with 32. And there you have it. You have 32 times 2, which gives you 64. Okay, so the sixth term is 64. And that's obviously the pattern that we see here. Alright, now for the explicit formula. Again, all this is another way to solve for the sixth term, okay? Using the explicit formula. So I'm going to start there. N is still 6. I'm still trying to find the sixth term. And then I am going to try to figure out f of 0. So really that's what I should have started with. I'm going to go ahead and do that right now. Alright, f of 0. Okay, so I have the first term being 2. So if I want to backtrack here, okay, and put a 0 here, okay, so if I'm going 2, 4, 8 to the right, if I want to go back 1 the other way, I would do the opposite of multiplication, which was divide by 2. So 2 divided by 2 is 1. So f of 1 is going to be, f of 0 is going to be 1. Okay? Alright, now I need that because remember f of 0 is part of the explicit formula. So now I can go ahead and substitute that in. Let me go ahead and change that n here to 6, okay? That's not how I want it to look. I want it to be an exponent, so I'm going to go to retype that. Alright, so now I have f of 0, so I'm going to go ahead and change that out. Okay, f of 0 is 1. Okay, parentheses. Um, Now I'm using parentheses for multiplication because I'm using a program that, it'd be more work for me to put in the multiplication symbol. Okay, and I don't want to use an x because that's, I don't want to use the x multiplication sign because that might confuse me with variables. Alright, so the only thing I have left here is the ratio, which I defined for the first problem being 2, so I'm going to go ahead and change that out. So this r is 2. Okay. Alright, so what I have here is 1 times 2 to the 6th power, okay? Alright, in fact, actually, nope, I want to get rid of that. And yeah, that's how I want it to look, okay? So from here, it's just simplifying. 1 times 2 to the 6, so 2 to the 6, okay? Will end up being 64, okay? And 64 times 1 is 64, and that's the same answer as at the top. Okay, same answer, just a different way to do this. Okay, now is this going to be linear or exponential? Okay, I mean the easiest way I can explain that. Okay, I mean we talked about the shortcut. When it's geometric, it's always going to be exponential. The proof is in, well, first of all, the pattern. I mean, if we're timesing it by 2 each time, okay, that is an exponential function. If we were to look at it as a graph, okay, here's what we would see: 0, 1. I'm going to see if I can make this bigger. 0, 1, 1, 2, 2, 4, 3, 8, and the rest will go off the chart. Okay, so what I have here is this nonlinear function. Okay. Do I even want to try to connect these? Again, I'm not using a mouse, so this is a little bit harder to do, but hey, that's pretty good. Okay, so there, that is my exponential graph. Okay, this is increasing exponentially. What that means is the increase as I go over 1 on the x, the change in y doubles. Okay, so that's why you're seeing the change increasing each time. Okay, so there you have it. Basically, this is how to figure out a geometric sequence using both the recursive and the explicit formula. So hopefully this was helpful.